look, the only difference between polynomials and rationals where you've got fractions are worked exactly the same. Except for a minor detail, except we can never put a bracket on a 0 well, to cover myself. Of the denominator. Let's say we're looking at f of x equals x minus 3 over x plus 2. We want to find, at this time, they start calling them critical points instead of zeros. All the critical values are zeros of the numerator and zeros of the denominator. So we set the numerator equal to 0, we set the denominator equal to 0. In this case, our critical values are going to be positive 3 from this one and negative 2 from this one. That's step 1. Step 2 is mark them on a number line. Negative 2 and 3. Find test values. How about negative 3, 0, and 4? Find if the interval is going to be positive or negative. So, well, gee, I needed to make this an inequality, didn't I? How about, let's say, find where this is less than or equal to 0. So I'm going to find where it's negative. Okay, so when I plug in the negative 3, I'm going to get negative 3 minus 3 over negative 3 plus 2. Plugging it in here is negative 6 over negative 1 is positive 6, which is positive. So this one is going to be a plus. When I plug in 0, I'm going to get negative 3/2. So 0 is going to give me a negative. In other words, 0 minus 3 over 0 plus 2 is negative 3/2 is negative. And plugging in 4 minus 3 over 4 plus 2 is 1 over 6 is positive. So for less than or equal to 0, I'm looking for negative. I can put a bracket on the 3. But I have to use parentheses on the negative 2 because it's in the denominator. No matter what else happens, I cannot include the -2 in this because it would make it undefined. So my solution, I'm looking for negative. So from -2 to 3. I can put a bracket on the 3 because it came from the top and I have the equals. But no matter what, I have to put a parenthesis on the -2 because it came from the denominator. Now, what's really weird is that since we're only looking for positives and negatives, the answers to x minus 3 times x plus 2 is less than or equal to 0, comma, x minus 3 over x plus 2 is less than or equal to 0, comma, and x plus 2 over x minus 3 is less than or equal to 0. Will only differ in parentheses and brackets. The y values for all of these are way different. The graphs for all of these are way different. But the solutions as far as where they're positive and where they're negative, if you said, for instance, -5 times -2, that's going to be a positive 10. If we said -5 divided by -2, that's going to be a positive 2.5. If I said -2 divided by -5, that is a positive 0.4. This part changes depending on whether you're multiplying or dividing, and in dividing, which one goes first. But the sign, when you multiply or divide two negatives, is going to be positive no matter what. And this basically says we're only looking for the signs. So the signs are going to change at the same x values. The solutions to these problems only differ in what you can include and not include as far as the endpoints. Isn't that a weird thing to try to wrap your head around? Odd, isn't it? But true. So the rationals work exactly the same way as the polynomials.